For those of you that are trickling in as we go, please go ahead and type in the chat feature where you're from. And if you are a prospective student, again, please comment what year or grade you are in as well.
Since people can't see, I'll name out some of the places: Roseville, Bakersfield, Austin, Texas. We got transfer students, we've got freshman students, Huntington Beach, Portland, Oregon. We've got independent counselors. And that leads us to saying, wow, welcome everyone.
So before we begin, I'd like to get some housekeeping items situated for y'all. Please note that this is a webinar setting. Therefore, your cameras and microphones will be inaccessible to you, and that means that we will not be able to see or hear you. However, we welcome you to utilize the Q&A feature or the chat should you have any questions. Professor Squires will be answering those questions at the end of the presentation. So go ahead and input them into that again, that Q&A feature or the chat. We also have an admissions counselor here today, Julian Aguirre, who will be moderating the chat should you have any admissions related questions throughout the presentation. But we also are joined by our executive director, Kuka Acosta, and she is more than happy to answer your questions as well. Lastly, this session, along with the rest of our lecture series, will be recorded and shared on the admissions YouTube account, UCSB for me. So please make sure to subscribe to that account, or you can also follow us on Instagram, which is UCSB Admissions, for updates regarding when that is uploading. That being said, I'm again excited to welcome you to our faculty lecture series. Today we have Professor Todd Squires from UC Santa Barbara's College of Engineering. Professor Squires has been a chemical engineering professor since 2005 and is also a faculty advisor for UCSB's student chapter of the Society of Cosmetic Chemists. He earned his undergraduate degrees in physics and Russian language and literature at UCLA in 1995 and his PhD in physics from Harvard in 2002. His research involves complex fluids with applications in consumer products, the function and dysfunction of lung surfactants, and water treatment membranes. Today's lecture will dive into the science and engineering of materials and products that most people use every day, from shampoo to shave gels, vaccines, and paints, and much more. He also has two kids that are in college, one in junior high school, and that helps him understand how exciting and stressful the transition into college can be. So, without further ado, I will hand you over to Professor Todd Squires.
All right. Thank you, Vanessa. And in fact, I believe all of my kids are watching this right now. One's out in Davis, one's in Boston, and one is in Goleta, 3 miles from here. So, anyway, it is a pleasure to be here. How do I, okay, I guess I do that. So, I thought I'd start actually just by talking a little bit about how I got to where I am, just for fun, because it's a bit of a weird path that I took. I was born in a tiny little town in Wisconsin called New Holstein. There was 3,012 people there, and my dad worked for a cheese company called Lake to Lake. We then, when I was about 10, moved out to Los Angeles, the San Fernando Valley. That was in the height of the Valley Girl era. This is my then girlfriend and me at the time in the high school fashion show, and you can see there's a whole lot of hair there. And in I so I did a Russian lit degree at UCLA. And I went and did a fall semester out in Moscow in 2000 or 1994. So it's 3 years after the Soviet Union dissolved. So there's me then. I then did a year in Cambridge in England, doing applied maths, as they call it. And that was like super, quantum field theory and superstring theory and stuff, but also fluid mechanics, which they have a very, very strong group in. And I found that I really I liked the sort of applicable nature of it. And so kind of kept me interested. I went to Harvard, so the other Cambridge on this side of the pond, did a PhD there. And while I did that, I had really supportive, wonderful advisors. I kind of traveled all over the ex-Soviet Union. I declined my salary over the summers and went out and traveled around. And so there's pictures here from around Mongolia. So in Tuva, I'll come back to that in a little bit. Um, Down near so Georgia, which is kind of down kind of by Turkey and Armenia and Azerbaijan. It's me riding a donkey. Down in Uzbekistan and Kyrgyzstan. So I had went all over the world. And speaking Russian, I was able to go and interact with lots and lots of people, and it was really, really kind of a special time. Um, I did a summer in Egypt while I was in grad school. Um, and actually, my wife went to high school with somebody who went on to be an animator for The Simpsons. And so for my birthday one year, uh, she had a Simpsons versions of me drawn. And so there's that. And then I did a postdoc at Caltech out in Pasadena. And then 2005, I started my position in chemical engineering here. This is the beach that is about a 5-minute walk from where I'm sitting right now. That's called Campus Point, and that is my youngest kid, maybe 3 years ago, enjoying the surf. So that's how I got here. So those of you who are thinking about college, it's such an incredible time because you change so much. You're ready to learn and really like you can do anything. So it's a wonderful time. Everything can be interesting and just enjoy it. Enjoy developing mastery and enjoy exploring things. You can see I had a very meandering path, but I pretty much liked everything I ever did. And so, you know, there you go. I had a wonderfully supportive network. And at the same time, there will be times that are hard and it's natural to doubt yourself. Everybody does. So wherever you go, whatever you do, it's going to happen. Know that everybody does that, right? But but you can do it. So anyway, things to ask yourself as you go through this is what are you good at? And what do you value? What do you want to do? And so here's what I'm going to tell you today. So everything in my talk today is awesome. Everything about yeah, I won't say the same about everything in the world right now, but the world really is a fascinating place. And even things as kind of dumb as shampoo, it's not dumb, but shampoo, right? There's such unbelievable and interesting, magical almost science that underlies it all. And so that's kind of, part of what I just wanted to tell you today was just about how interesting everything is. I'm going to hit a little thing that's going to be very touchy-feely about how unique and valuable and special each of you are. If you wind up coming to UCSB or if you're interested in engaging, there's lots of ways to do it. And I'll also talk a little bit about chemical engineering just more broadly. All right, so that's kind of the big picture story. But I gave all of those moments in my life in part because there's all sorts of kind of funny little things that wind up tying to chemical engineering, right? So cheese is a fermented food product, right? And so there's fermentations, based on where I was a kid, right? This is near the Armenian border in Georgia. This is some fresh cheese that they had made. And so there's fermentations there. If you look to the right here in Tuva, this is right by Mongolia. This is another fermentation. They had fermented. There was a family that we spent a few nights with up in the mountains, a nomadic family. And well, we were in our tent, but this is inside of their yurt. But they had fermented mare's milk for like as a party for the, going away party. And so anyway, there's a fermentation there. This is the first still I ever saw. So this is a distillation, another classic chemical engineering operation, where you take a alcohol, in this case, alcoholic mixture. You can distill all sorts of stuff, but you take an alcoholic mixture, you heat it up, the alcohol vaporizes more quickly, right? And it kind of comes up, it condenses on the bottom of this water, and then it kind of goes into this track and it pours into here. And that was some strong, strong stuff. I will tell you. All right. So, if you look at all of the hair that's going on here in this fashion show, right? You cannot, that does not happen on its own. You need all sorts of science and magic to make that happen. So there's, hairspray, styling mousse, that there's science behind that. I won't talk about those specifically, but Moscow, right? So this was we had no hot water for about 3 weeks, and we finally got some, and this is what it looked like. That's the bathtub. Sorry for the risque picture of my leg. So water treatment is a thing that it's a big thing, right? And so what I'm going to start though is this is my little trip. When I was in Egypt, I saw hand sanitizer for the first time in my life. I don't know when it was invented, but I had never seen it before. And I was just amazed that I could take this stuff, put it on my hands, go wah, wah, wah. And then suddenly I'm like, wow, my hands are clean. And decided I would never again wash my hands. Um, but I want to talk about hand sanitizer first because it's relatively simple, but it's still kind of complicated enough. All right. So, here's the thing. So that's Harry when he was a little dude, and when we were in Australia. So you've been taught to say that matter, right? There's kind of three flavors. There's three phases. There's solids, there's liquids, and gases, right? So solid, you push on it and it pushes back. That's how you know it's a solid. A liquid, if you push on it, it flows. Okay, that's a liquid. And then a gas, well, it's like a liquid, it's just less dense. All right. So, and you're kind of right. I mean, that's kind of true, right? But then what about hand sanitizer? What is it, right? You can say, well, it's a solid, right? It's sitting in this person's hand, and it's not moving, it's not spreading, it'll pile up, right? But, also, and you look at those bubbles down at the bottom there, the bubbles have been there for a long time. They're not rising, right? So it's kind of like a solid, right? There's stuff that's gravity's pushing down on the pile, it's pulling up on the bubbles, but nothing's happening. So it's kind of like a solid, right? But at the same time, it's kind of a liquid too. If you push it, right, it'll pump out of the bottle. I can spread it on my hands, right? And so that's called a yield stress material, right? And the answer, so yeah, it's kind of a solid, kind of a liquid, and it just depends on what you do to it. All right. So, all right, how do you get that? Right. So here's what's in hand sanitizer, right? It's 60, 70% alcohol, depending. It's got to be at least 60% or else it doesn't do anything. Water fills up most of the rest of it. Glycerol, the powder, right? There's a base, a liquid base, like, opposite of an acid, a base, right? And then there's a tiny little bit of this stuff called carbomer. So it's a 0.5% or less um, of a like a powder, right? And so that texture you get from hand sanitizer comes from this tiny little amount of this tiny little powder. All right. And so how does that work? Whoops. All right. So my animations are a bit messed up here, but so what it is, that powder, those are highly swellable polymers. All right. And so it's like it wants to swell. It's basically diaper gel. All right. And so it's kind of like Orbeez. If you think about Orbeez, right? Those little, they start off that big, they grow to be about, they swell by a factor of 1,000 or so. Right. And so you can see the Orbeez at that point, they've all jammed together, right? At some point, there's so much pressure, they start popping out the top, right? But essentially, all those microgel, or these are macrogels, I guess, they're all kind of swollen together and smashed together, and they jam each other in place, right? If I push on it hard enough, I can get them to rearrange and they'll flow, right? But if I don't, it'll just sit there locked in place, right? That's what carbomer is doing in the hand sanitizer, right? So chia seeds do the same thing. I had a lot of fun with making time-lapse videos for this. So this is chia seeds that are swelling. Um, a funny little fact here, it kind of stops swelling because water has to diffuse all the way through that to get in. And it's, takes forever to do that. And so that's kind of like that is a macroscopic version of like when you make macaroni and cheese and the cheese sauce, the little like powder packet, you kind of get those like gummy clumps. That's a big scale version of that. All right. So that's what's responsible for the texture that you get in hand sanitizer. Um, and I think what I wanted to do here is uh, right. So it turns out, it can easily support salt. All right. But um, if you put salt in it, right, and this is kind of a party trick you can do, if you put even a grain of salt into a hand sanitizer, just a little jar of it, right, it'll kind of burn a hole through it, kind of and fall down like that. All right. And in fact, uh, yeah, so that's a real video of it. That's 10 times faster. You got to be patient. But I can take here, I'll even take I'm going to do a little live demo. So this is hair gel. This is LA Looks hair gel, and I've had the same hair gel for 10 years now. This is my demo hair gel. So I'm going to do a little I don't know, can you see me? Um, so to so this is table salt, right? Um, I'm just gonna go boink. I just poured some table salt in there. I think you can see me, but I guess I don't know, right? So I put table salt in there. If I just shake it up, right? Um, it's getting there, right? So if I shake it up, if you can see it in the thing, right, it's basically liquefied it, right? So adding salt to something like that, it collapses those microgels, right? So it's kind of like adding salt will take those Orbeez and make them shrink again. Kuka, could you see that? All right. It makes them shrink again, that releases it, and then the texture's gone. Okay. So that's a really simple product, really. And so we're going to go into something a bit crazier now. So there's a lot going on with my hair there. It doesn't do that on its own. And to get all of that stuff to happen, there's got to be a lot of stuff in the product, right? So this is my shampoo, middle-aged man. I have dandruff shampoo. So that's Head and Shoulders. All right. And so we're going to go through and talk about all these things that shampoos have to do, right? But don't take my word for it. We're going to let commercials tell us, right? And so a warning here, this should be funnier than funny, I think, but I'm not going to have any way of hearing you. So this may be bombing and I won't know, or it might be like horribly offensive and I won't know. Because some of it, I will say, these are commercials from the 50s to the 80s. Um, times have changed, and that's part of it. Okay, so here we go. Number one, what does shampoo have to do? Well, it's got to cleanse the shame of your dirty hair. So
here comes Mr. Wonderful. Oh, my Did you ever feel like putting a bag over your head to hide your dirty hair? That's how I used to feel until I discovered Liquid Prel shampoo.
So there's actually, so yeah, so all right. I'm sure that that woman is, far better in, the eyes of Mr. Wonderful than if he had actually seen her hair, right? But I had tried to find a different Prel shampoo and I just stumbled on this gold mine of like sociological, whatever time capsules. So, all right, you've got to clean your hair. Obviously, shampoo has to clean your hair, right? Why is it hard to clean hair? All right, oops. All right, so it's hard because, a lot of stuff you have to clean off your hair is oily or greasy, right? And oil and water don't mix. So if you just go and you rinse your hair, right, the oil is going to just kind of stay stuck to your hair, right? So there's something you need. It's called a surfactant. And my family always makes fun of me because I just always talk about surfactants. But you need a molecule, something that will actually make it easier to get the oil into the water, right? Generally, oils like oils, water likes water. You know, there's this little region in between where they really don't like each other. All right. But oh well, they have to do it. All right. And so what a surfactant is, it's a molecule that has half of it that really likes oil and half of it that really likes water. And so, you know, if you imagine taking that molecule over to that little oil water interface, right? You can imagine that's going to say, oh, hey, the water half is going to want to go in the water half, the oil half is going to want to go in the oil half. And so that's what it does, right? So if you have surfactant in a solution and then there's oil around, generally it will go and the surfactant molecules will stick to those surfaces, right? That lowers the surface tension, so it makes it easier to make drops or to make, yeah, so my son just texted me and say surfactant mentioned. Um, uh, Although I'm gonna, all right, stop texting me. Um, so, um, so it lowers the surface tension, makes it easier to make droplets or bubbles, right? Um, so the surfactants will coat droplets, right? And so that way, then now that little drop can kind of go out into the water, right, and float around, right? And so it'll be rinsed away. And then also it can have the effect of protecting them. It kind of like forms a little shell and it protects them from recoalescing. Okay, so that's what the surfactant does in the shampoo: coats and lifts the oils, carries it away with a rinse. All right. So next up, right, your hair should smell good. And this is
You washed your hair for me. Uh-huh. New extra fresh liquid Prel. For freshness they'll notice today and tomorrow.
all right. So, you know, for that special person, wash your hair. Or yeah. So why is it hard to do that? Right? Why is it hard to make your hair smell? Oh, just stick in some perfume, right? Well, the thing is, perfumes, most fragrances are oily, right? And so they are gonna, you know, separate from the water. All right. And in fact, this is a video. So this was in my discovery seminar, which I'll talk about. We distilled out essential oil, right? So this is orange essential oil. You can see it floating on the top, right? And then there's water on the bottom called the hydrosol, right? And so, all right, so you've got oily stuff, but you have to put it in the watery shampoo. Well, how do you do that? Well, you might, you know, so surfactants, of course, are the answer, right? So you have these little surfactants in your shampoo, right? Little molecules. When there's enough of them, right, they kind of bump into each other. They say, oh, hey, how's it going? And the oily tails say to the oily tails, oh, hey, what's up? And if there's enough of them, they actually kind of like make their own little oil drops to coat, right? So that's called a micelle. If you've had micellar water, if you've used that to clean your makeup, you know, I do all the time, then you know, that's these little micelles here. Okay. And so generally in any soap solution that's going to do anything for you, right, you're going to have, it's going to be a micellar solution, and there's lots and lots of little like balls of surfactant around. All right. And so this is a cryo TEM. So this is a super high tech thing where they, you know, you flash vitrify, you freeze it so fast it doesn't even freeze a layer. And then you look at it with an electron microscope and you can see here's these little balls, right? So those are 5 to 7 nanometer micelles of a particular surfactant. All right. If you add oil to them, the oil wants to go into there. And so, hey, that's great. Right. And so the micelles get a little bigger, right? 6 to 9 nanometers, right? Still pretty small. So, okay, good. You got a lot of surfactant around, and that's good because that's good for solubilizing like fragrance oils. All right. But so one thing that's funny about that is, well, you know, the shampoo, you know, its job is to kind of lift the oil and take it away from your hair. But now you're saying, well, but we also want to deposit this fragrance and leave it on your hair. So somehow you're kind of taking some off and putting more on. How does it do that? Right. Later, we'll talk about conditioning shampoos, and that's even more extreme a version of that. All right. So it should feel rich. All right. So here is
How gloriously different liquid Prel is from thin, watery, and wasteful shampoos, or thick, sticky ones that can actually dull your hair. Wonderfully different liquid Prel is extra rich. Every emerald green drop bursts into luxuriously rich lather that leaves your hair looking radiantly alive.
Radiantly alive. All right. So you could see, yeah, if you try to pour just like, you could use just straight rubbing alcohol or straight ethanol as a hand sanitizer, right? But it would pour through your hands. That would be a pain, right? Um, so similarly, you could have really runny shampoo and, it's hard to handle. All right. And so having one that's thicker is nice, right? But also it feels better, right? You sort of like, oh, stop this one. All right.
Some shampoos are thin, but Liquid Prel is luxurious. Try it. Liquid Prel's rich lather lets you become anything you want.
Right. So that's a classic image, this pearl falling through the shampoo. And that's the one that I had originally been looking for and that sent me on this whole journey. Right. So that's a measure of the viscosity of the shampoo. And you can see Prel shampoo has a much higher viscosity than that really cheap old runny shampoo. All right. Uh so in fact, shampoo has the same viscosity as honey. All right, so this is honey from my beehives, but all right, here we go. So you can see, right, they pour pretty much the exact same speed, right? So that is a very rich and luxurious shampoo. There's got to be all sorts of stuff in there, right? All right, so turns out, why does it do that, right? So this is the cryo-TEM, these small little spheres of surfactant, those are the micelles. All right. If you did the same thing in shampoo, this is what the micelles look like. They're big, long strings, and they're all kind of tangled up. All right. These are the same surfactant actually between the two, but there's a little extra secret sauce added to the right. And, I will, you'll learn about it. But so they actually call them worm-like micelles because so this is a pile of worms. They have to speed it up so that you can see something happen, right? But this is to do like worm composting. And it's somebody's video online. It's not mine. But anyway, so if you've got all of these things tangled up and you're trying to get it to flow, well, they have to disentangle, maybe they break, right? But it's slow, right? And so that's where the viscosity comes from, right? Is instead of having these little spheres that can go past each other, you've got these big worms that are tangled up like spaghetti. All right. So why does that happen? So it turns out that the shape of the surfactant molecule determines what shape the micelle is. All right. And so it's sort of like how big is the head, the part that likes water, how long can the tail be, and then how much volume is in that tail. All right. And so if this packing parameter is small enough, right? So if the head is big enough, it wants to form spheres like this. Okay. If it's kind of right in between, right, you make the head a smaller, 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 then if it tries to form a sphere, the tails aren't long enough and you wind up with a little hole in the middle, like a vacuum. And just, the world does not want vacuum. And so what winds up happening is it kind of collapses on itself and it starts to grow out like a thread, a worm. All right. So in a certain kind of surfactant with a certain shape will make threads. And then if you have ones where the head is basically the same size as the tail, then it makes sheets. All right. So these are like all of your lipid membranes that, these every single cell in your body and all the organelles and all the cells are two-tailed surfactants that form sheets. And, that's that. This is also like your conditioners, your lotions. Those are all in this phase too. All right, so here's the secret sauce, right? It's the same surfactant. I said, okay, it's the shape of the surfactant that matters, right? But this is the same exact surfactant. So what trickery are you playing to make it so that, the shape changes? So it turns out, right, all of the surfactants in shampoos are general, not always, but a lot of them are negatively charged. And so the head groups want to repel each other. All right. And so the head groups are actually they feel bigger than they really are. All right. And so if you add salt, all right, just table salt, that screens out those charges, the plus charges in the salt, the sodium, for example, will kind of go and it kind of gets in between there, and it tends to shrink the head groups, right? Shrinking the head groups then can push it from going from wanting to be spheres to then going and making strings. All right. And so that is, whoops, so this is a batch of shampoo I made a couple days ago, right? Did not add salt. And this is the one where I added salt. The only difference is about like a tablespoon of salt. All right. So you may think this is like some fascinating, like, oh man, there's a lot in there. This is so thick and rich, right? The difference is like a half a penny's worth of salt. So, all right. So there's that. Yeah, there's the magic ingredients. Do, do, do. All right. What next? Oh, yeah. So here you go. Shampoo, right? So it's got the same viscosity as honey, right? And so, right, imagine lathering honey into your hair. All right. Um, you know, it will feel very different than lathering shampoo into your hair, right? And so why is that? All right. And so we have to wait for Steve Carell here to and he really did this. All right. There we go. And cut. Yeah. All right. So it turns out shampoo, it's what's called shear thinning, right? So the viscosity actually drops by a lot when you make it flow. So if you're pouring it, the flow, the viscosity is about 10,000 times higher than water. Okay. But if you spread it, if you do this, right, the viscosity drops factor of 100, probably even more. Okay. So it's shear thinning. That's why you can rub it in and you don't tear your hair out. Okay. Why does that happen? Right. So back to the worm-like micelles, when you flow it, right, what it has the effect of doing is it essentially aligns all those micelles, right? So you can see in this cryo-TEM, all these things are kind of lined up like that. Once they're like that, it's like you've combed your hair, right? So it's really easy for stuff to slip past each other. And so that's what's going on there. Okay. And so you might say, Todd or Professor Squires, depending, sure, you have some fancy cryo-TEM, which I don't, right? But what if we don't? All right, so I'll show you a cool trick that you can do at home. And basically, polarizers, so light can be polarized, right? On the image on the left, I've got a glass bottle and a plastic bottle. There is a polarizing film that only lets light through that's polarized left, right. Okay, so when I turn on the light, only light that's coming, it's like polarized that way comes through. Okay, if I put another polarizer perpendicular to that, then it'll look black. Like the light can't get through because it's like, oh, only this can get through. And then this says only that can get through. And so none of it gets through. Unless you have something in between that rotates the light, right? And what would rotate the polarization is if the material has some anisotropy on a nanoscale, right? So plastic here, so here I'll show the video now. So this is just with no polarizing film in the front, okay? Now I'm adding cross polarizers. You can see that when there's nothing in the way, it's black. The glass is black because the glass is isotropic. It looks the same in every direction, right? But the plastic has all this, this alignment frozen into it from when it was made. If I rotate that polarizer perpendicular or parallel, you can see everything. Okay, so that's a real cheap, easy way to see, if there is some like nanoscale alignment in your material. Okay, so this is now from my discovery seminar. This is a demo I did, and I asked, the students videoed it on their phones, and then I asked them, and so I got 3 different ones. So Kaya, Creative Studies, College of Creative Studies, Sarah, who's undeclared, and then Isla. Isla had the best because she had the best view, and so I'm gonna play hers. So this is now cross polarizers. That's shampoo, and that's me just sticking a mechanical pencil into it because it's what I had, right? And so you can see it lights up like that. right? And why it's doing that is as I push down on it, my cells are going, they're aligning, they're flowing, and that then is rotating the light and it kind of pops through. And so, so I have a suggest. So this is, Oscar season or whatever. So for your consideration, this is my suggested improvement. Here's the classic commercial,
thin,
right?
but liquid Prel is luxurious. Try it. Liquid.
So for an extra like 20 cents, you could have done this.
Some shampoos are thin,
My timing's not quite right.
but liquid Prel is luxurious. Try it.
Watch this pearl as it floats slowly down into a bottle of liquid pearl shampoo. Watch it descend in thick emerald green liquid. It's extra.
All right, I won't get an Emmy or anything, but yeah. So what you would see there is that's flowing down. There's the flow going around the marble that's aligning it in these different directions, and so there you go. All right, so great shampoos give you a thick lather. This is an absurd one.
You're not seeing things. Her short, sleek hairdo is actually made out of the rich lather you get from Liquid Prel.
Yeah, I don't think anybody would have been, fooled by that hairdo. But so, right, so how do you get lather like that? Right. So again, it's thanks to surfactants. They lower surface tension. So this is pepper on a water surface. I'm going to drop a little surfactant right in the middle. And basically the surface tension goes lower and so like the surface pulls itself away. Tyler, senior chemie right now, sent this video. This is her drip coffee. So there's surfactants on the coffee, and you can see these drips come down, right? But because the surfactants are there, it can't actually coalesce with the water right immediately, right? There's a little film of air in between there. And so the surfactants can stabilize interfaces, make it harder to break the films. So in shampoos, a lot of times they'll add a secondary surfactant that's fast at absorbing, it's better at stabilizing, right? And so this is actually shave gel. This isn't, I didn't have shampoo here, but anyway, so that though goes to the air, right? And they stabilize the bubbles in the film. All right, so there's that. Lather is not required, right? Lather actually has nothing to do with cleaning, right? It's a signal to you that the product is working, right? But it doesn't do anything, right? So, if you have lather in your dish detergent, that's bad. So after the discovery seminar, after shampoo day, I put all of the glassware in our portable dishwasher, and the shampoo made it overflow. There's the Brady Bunch, Peter or Bobby, I forget who. But more seriously, like in bioreactors, industrial reactors, fermentations, et cetera, industrial processing where you may have like, a 50-ton reactor, some huge reactor. If that thing bubbles over, it's bad. So it's actually important to be able to control foams, and there's people who work on that in my
You're
work.
not.
All right. So your hair should shine. I got to keep an eye on the time, but tell me, step is great.
Negative. Did you shampoo today?
Yes.
Step under the shine tester. Hair does not shine.
Sorry. Yeah, and again, I have no idea if this is landing or not, but so yeah, so the woman walks up to like a 60s era, computer wanting a date, right? And the punchline at the end of this commercial, by the way, after she shampoos with Prel, the computer asks her out, of course. So all right, how do you get your hair to shine? Right. So these are electron micrographs of hair, right? Near the scalp on the left, you can see it's pretty smooth, right? There's these kind of flakes, right? These cuticles, right? They're pretty, I mean, they're jagged, but right. The middle of the hair where it's kind of been out for a while, it looks a bit more damaged, right? You can kind of see there's like, oh, bits are broken. Near the tip, most of those cuticles are gone, right? And, that's in bad shape, right? And so how do you make your hair shiny? If stuff is rough like that on a kind of micron-ish scale, it'll look matte, all right? If it's smooth on a micron-ish scale, it'll look shiny. And so deposit stuff onto it that will kind of like smooth over those little imperfections, right? And so one thing you can deposit is polymer, and it'll be a whole lot like the Orbeez or the microgel. You'll tend to put on a positively charged polymer because it sticks to the negatively charged hair, and then it kind of swells up, and they have this little like layer of slippery polymer water. All right. So that works when your hair is wet, right? There's also oftentimes like silicones, so like oil drops in a shampoo. That's actually my microscope image there. That if you can get the silicones to go and absorb and spread, right? Now you'll have this little layer of silicone oil, and that's a really good lubricant, and it's also shiny. And that'll stay effective even when your hair's dry. So you've got to get that stuff to stick to your negatively charged hair. All right. So problem is, well, conditioning oil, again, you don't want your oil to separate. So this is olive oil in shampoo, sped up, right? Whatever you do, if you put little drops of oil in a shampoo, they're going to rise. So how do you stop that from happening? All right. So one way is with they'll put in like the opaque shampoos that you see, and a lot of times they'll be a little bit shimmery. They have a network of little like wax platelets. That kind of form a network like that. And so you can kind of see it here, right? And those hold those drops in place and keep them from rising, right? They also, if you have an anti-dandruff shampoo, you might have zinc colloids, little particles in there, and it'll keep those from settling, all right? Um, all right. But now, okay, now you're adding in positively charged stuff. I told you the surfactants are negatively charged. Isn't that going to gum everything up? And in fact, do I have it here? Oh, here's some. So I I took conditioner, which is positively charged, and shampoo, right? So conditioner is like a gel, and then shampoo is a thick liquid. I don't know how well you can see it, but when I mix those together, I tried to do a better job for you, and I was going to do it live, but basically it's still a pretty serious foam in there, but you can see it's just kind of like real runny liquid. Right. So you don't want that to happen because then it ruins everything. You don't have your rich shampoo. Right. And so this is a cool thing. If you have on the left, if you have a surfact or a polymer, it's positively charged, it wants to swell up because all those charges want to be away from each other. You add a little bit of negatively charged surfactant, not a big deal. All right. But you keep adding surfactant, right? Now, like, oh, the surfactant, the negative charge goes and it kind of attaches to the positive charge on the polymer, right? And then now these are all neutral, right? So the thing that makes the polymer want to swell isn't wanting to swell anymore. And moreover, you've got these oily bits hanging out. Those don't want to be around each other. And so that would crash and blah, and come down. All right. But if you keep adding surfactant, then instead of just having a surfactant molecule, you'll wind up with micelles. Right. And so then the polymer swells again. And so that's when you have pretty much any shampoo you have is going to have polymer micelle interactions that are kind of like this. Okay, so if you have enough surfactant, great. All right. But, right, you also want to be able to deposit the stuff, right? There's very little, like the silicone oil is one of the more expensive things in the shampoo, right? Won't most of it just wash down the drain, right? And so how do you get stuff to stick? All right. How do I get the zinc colloids to go onto my scalp and kill my dandruff? Right. So what happens when you rinse? All right. So we'll take what I just showed you, where you go from this like polymer and flip it around, right? We're starting here. We're going to add water. And when you add water, you're going to get to a point where now there's not enough surfactant to form micelles to solubilize the polymer, right? And so now you have this thing that's neutrally charged with lots of oily bits. It'll collapse and kind of gum up and forms this sticky, it's called a coacervate, right? These sticky chunks, and those are a lot easier to stick to your hair. So this is me. I took that unthickened shampoo that I made, and this is Head and Shoulders on the left. The light things are the silicone oils, right? I just hit it with unthickened shampoo. And so you can see this is now diluting, right? So the silicone oils are coming out. That's a bubble. Silicone oils are coming out, right? That's the waxy platelets and some of the zinc in there, right? Compare it with, this is now if I add water. If I dilute it with water, right? You see these like these little fluffy chunks, right? So that's the coacervate is sticking stuff together. As that's going through, it'll hit your hair. When it hits your hair, the positive stuff will stick. You keep rinsing, the bad stuff goes away, but you've deposited what you want. So that's how you can get the fragrance on. It's how you can get your all sorts of stuff. All right. So, all right, I got to hurry up. So, yeah, this is high tech stuff. This is funny.
Yeah. It's a unique clean rinse formula. And who's got it? It's our clean rinse formula.
It's our clean. And the thing that's funny is the molecular formulas are actually they're actually appropriate. All right, so yeah, you want it to rinse off. This I can, I mean, I can tell you about but all right, so here we go. Look at all this stuff shampoo has to do. And the last thing it has to do, and we'll let this poor, whiny, budget-concerned husband tell us.
Susan, I just went over the bills. We've got to tighten our bill.
Trying, Stanley?
Well, try harder. Do you have to use so much shampoo?
I'll concentrate. Just this much made all this great lather.
Yeah, do you have to use so much shampoo? All right, so yeah, this stuff is actually really cheap, right? And yeah. All right, so all right, so this is the part where where you can really see how times have changed. So how do you know? What can a successful shampoo do for you?
The compliment in a bottle of liquid Prel.
Compliments.
Pretty hair. Yeah.
That's compliment number one.
All right. So random men on the street will catcall you because your hair is so nice. All right. Number two, your coworkers will
Liquid Prel leaves
We'll ask
hair
you out.
luxuriously clean.
Oh, Miss Bradshaw. Nancy.
Are you busy after classes?
Compliment of liquid Prel.
There we go. Strange men will smell your hair in elevators.
Use it one day, and the next day your hair will still smell fresh.
And again, so I find this just so absurd, and finally, if you're doing well at work and you're trying to explain your latest results to your boss, he's going to comment on your hair. So come on.
Your hair smells nice and clean.
All right. So yeah, times have changed. And all right. And so this one, I'm not going to play the whole thing because I have to finish up and I have actually stuff to tell you. But this is like the most absurd one.
We want every woman to know that her hair doesn't have to be dull,
We just care about you, women.
even if we have to prove it.
Yeah, so they take her to this like creepy, like castle looking place, and then this guy like shampoos her hair.
Film to dull your hair, you'll know that Liquid Prel can give you bright, shining,
See, look
beautiful
how much
hair.
happier she is now, right?
But please, prove it to yourself. Don't make us have to prove it to you.
All right, so here we go. Now, this is a point where I say, all right, check in with your users, right? So, I mean, who doesn't mind kidnapping as long as your hair shines, right? This is a fantastic article that you can get from the New York Times, right? Tampon of the future, which should make, all men are like, right? But so, one of the, it talks about, all right, so this woman, Lillian Gilbreth, who was one of the first female engineers with a PhD in the United States, Berkeley grad, twice. She got a PhD, but she was living with her husband out in New York. And so she didn't meet the residency requirement. So she didn't actually get her PhD from Berkeley. She had to then go to Brown and get it there. But so she did two PhDs. Any event, so she had the crazy idea of talking to women, right, about what do you like with menstrual products, right? And so like, oh, turns out, big diaper-like products with names like the Flush Down Ideal and the SS Napkin that didn't really go over well with women, right? And and this article talks about, so there's a scholar at MIT, this is people who suffer from a problem are uniquely equipped to solve it. The most novel innovations come from the users, right? The reasons are twofold. They know the needs firsthand and they have skin in the game, right? And so back to Gilbreth, she gathered lists of, the various tricks that women did, like, oh, they were cutting them up and doing all sorts of stuff on their own to make them better, right? And, and so she was doing market research, right? And, and she used those as inspiration for new product lines. So wow, it's not a like shockingly crazy idea, and yet, it's one that's not you know. And so anyway, there's lots of examples like this. So diverse markets require diverse inventors, right? And so this is Tristan Walker, started a shaving company. Procter and Gamble bought it, right? And he says, look, I can't use their products. The fundamental problem with multi-blade razors is that if you have curly hair, right? Basically, if you have curly hair, those multi-blade razors that I use, they lift your hair and they cut underneath, right? And so you wind up with ingrown hair all the time, right? And so he says, yeah, neglecting all of these people who can't use those things, right? So there are real differences, right? And so anyway, this is a challenge I give to my class. Oh man, I got to hurry. What makes you special, right? You really are unique, and I mean, there's a zillion ways that that you are diverse and that you are unique, right? Because you belong to different communities, different hobbies. It can be your kind of background, but it can also just be like the community you grew up in, right? That, you understand these communities a way that other people would have to spend time and money to learn, right? And so that's very valuable, and just appreciate that about yourself. And these were examples of things that came out of this class that I teach. All right, so I'm going to tell you real quick about stuff at UCSB, things that we've been doing in this regard. So there's various ways to engage with this kind of science. There's technical. I've got all right. Oh yeah. So, all right. I'm gonna. All right. So this is the discovery seminar in high speed. Kind of like we have a senior lab. One thing that students can do is there's one experiment that they can choose, which is the formulated products one, where basically I give you a product, you have to do all sorts of characterization on it. I give you basic raw ingredients, and you have to find basically figure out a way to match the properties of the material. So this is Natasha and Rohan doing making hand sanitizer last year. Taylor's in the back measuring the rheology. This term, they're making a non-petroleum based version of Vicks Vapor Rub. And all right, so I have a technical elective, which is about the conceptual design of formulated products and also kind of holistic understanding of it. So this is measuring the rheology of easy cheese, very satisfying. Also doing some microscopy. This is easy cheese. It's an emulsion. It's dissolving in water. And kind of we talk about how do all these different things work together to achieve the magic that products achieve. Work a lot on building mental models of what these things look like on that small scale. Okay. I teach a discovery seminar. So this is for first year students, generally from all over campus. There's essentially very little required other than come 2 hours a week for 5 weeks. And we make stuff. We start with the simplest stuff. So these are simple single phase materials, hair oil and scented candles. Next week, so 2 days from now, because we're in the second session, we're going to make lip balm and lip gloss. The week after that's polymer week. I recently started doing a peelable face mask. Hand sanitizer is always fun. Aloe is kind of boring because it's the same as that. And then surfactants, we do the foam soap and the and shampoo. And then the last one is the lamellar phase I talked about. So we do body butter, or, whatever lotion you like, and then a conditioner. My SpongeBob theme things were then at some point vetoed. So we have Harry Styles there. All right. So there's pictures. Actually, this is from the admissions office. of the Discovery Seminar in action. There's the Society of Cosmetic Chemists, which is a student group I'm the faculty advisor of. This is a couple of their formulation events. They did lip gloss and blush. And so you can follow them on Instagram. It's a wonderful group, a lot of fun people, and the thing is, well, it doesn't run itself, but I don't have to do too much. I'll notice somehow is I have her here. She was a guest speaker because she was one of the founding presidents of it, and she's now working for Estee Lauder, and she has been donating. She sent over some extra like Clinique, and so you know, they raffle those off. But anyway, so that you can see it's a lot of fun. If you're curious about Chemi, but you're not sure you want to commit, right? We have a first year class that my colleague Joe Chada teaches, which is kind of how chemical engineers think, right? Chemi 5, right? And it's all based around biodiesel. So starting with with vegetable oil, running a reaction where you actually kind of take the vegetable oil, you kind of break it apart, and you add you make biodiesel out of it. You transesterify. After that, then you do a phase separation, and so the biodiesel's up on the top. The bottom is ethanol and glycerol. They then do the biodiesel. You need to get rid of the fatty acids or neutralize them so it doesn't chew up your engine. And so you run it through an ion exchange, you get that. The glycerol and the ethanol, well, we want to use the ethanol again, right? And so there's a distillation, just like the, mare's milk and Tuva. And finally, then we're left with the glycerol. What do you do with that? Okay, well, let's add it, right? Add it to a product. So then they make soap and use the glycerol for that, right? More generally, Chemi. So, there's a lot of math, not going to lie, right? But not in all fields, I guess. But so this is just some of the different research projects and efforts that are going on. This is a octopus that I caught in the tide pools about a week and a half ago, right? And so you can see it changes color depending on where it is, right? So three of my colleagues, there's actually a bunch of people who do this kind of stuff. There's a certain kind of protein that then kind of collapse and form these things that interact with light. And so it can do that dynamically. So there it's gone dark because it's under that kelp. So there's that. Several of my colleagues are working on plastic, the problem of plastic waste. How do you recycle it? How do you upcycle it? Right. Michelle O'Malley, a colleague, she's more on the bio side and has all sorts of stuff on, how do herbivores digest grass? Right. It's, really non-nutritive for almost everybody, but they've got these fungi that live in their guts that are able to do it. And so she does all sorts of work isolating them, figuring out what genes are responsible for what, with the ultimate idea of then being able to make stuff. Couple of my colleagues have companies. So Eric McFarland has a company that takes methane and it kind of rips the hydrogen off. So it's a way of making hydrogen gas, like for hydrogen power. And then pure carbon. So there's no carbon dioxide. When you burn methane, you make carbon dioxide, right? And so it gives you graphitic carbon, in fact, which is valuable. And then Mahdi Abu Omar has a company that kind of takes waste biomass, lignin, and makes vanillin out of it. A whole bunch of us are involved in a big DOE-funded membrane project, which fingers crossed will continue to be funded. Craig Hawker and Eric Presley at UCSB founded Olaplex. They've since sold it. And our students go on to all sorts of stuff, and I ran out of time for that slide, so I will stop there. I gave you -1 minute for questions. I'm sorry. But I can stay if you want.